This is what started this whole endeavor. This faster fitting not properly sitting in the extruder, and this is the 3D print that did it all, that started me, and this is what my other self had to say about it.
This is why 3D printing is annoying. Look at this thing. Many cables and tools and stuff. The whole day upgrading and dealing with parts just to make a direct extruder. The cleanup is gonna be a mess.
And it all started with this clean desk and testing this models to see if my 3D printer is gonna work with them. And now those models didn't work, and I kind of sank the model into the platform and I thinned the base. And this is almost done 3D printing, and then we're gonna get to installing it, which is gonna prove quite a bit of a challenge. On the left is the original and on the right is the modified piece, and you can see the cut on the left hand side right there to make room for a pancake extruder or pancake motor. These are a few failed, not necessarily failed, but bad designs, and this is how we started. What I regret is trying to put a pancake extruder because they don't really have a lot of power and they fail all the time, plus they overheat, and that is not fun at all because it took me another 3 hours or 2 hours to figure out what was wrong after everything seemed to work fine. And that is why my other self was saying that it's tired of 3D printing, when in fact I'm not tired of 3D printing. I'm just tired when each problem that you try to solve uncovers a few other problems. So make a plan and stick with it and do not deviate from it. Taking these wires apart was quite difficult and intricate. Eventually I had to remove the thermistor from the heat block to use it on the new E3D V6 heat block, and that proved quite useful. In addition, I removed all the wires from the motherboard rather than cutting them and installing JST connectors. That helped a lot. The problem is that the conduit you can see in the video is quite hard, so I removed it and I never got to put the wires back inside it because it was difficult. And here's when I'm making the cut that you just saw in the previous picture to make room for the pancake extruder, which again proved to be a headache. Managing the wires here and then testing if the nozzle still works, if I made the connections properly. Drilled a few holes to add the fan to cool off the pancake extruder, which I don't know if it actually was overheating before, because that fan got activated when the nozzle cooling was activated, and the first layer the fan never works, and I decided to use the second fan from the nozzle, and that may have caused trouble for the pancake extruder, which stopped working, or it wasn't reliable. So I kind of had to reduce the flow to 84%, and then the parts themselves became smaller. And this is just a dry test without filament, and to my bafflement, this works with the TwoTrees Sapphire S. If the nozzle is cold, it's still fakishly printing. And here is when I discovered that I had problems with extrusion. I thought initially that I'm over extruding at 100%, when in fact it was the pancake that either too much power makes it go in resonance and then it doesn't come out of resonance, or it doesn't have enough strength or enough coils to push harder. And all these chains were a waste. Now these are the 3 links that I printed with the new motor. You can see on top I installed the beefier motor that I had from replacing the 0.9 degree in the video, and this is the first design attempt, and this is the frame attachment for the chain, which I modified, and I installed a little square with a hole in it to put the PC10 faster fitting, and put the Bowden tube in that fitting and make the filament travel smoothly all the way to the Bowden tube. This worked, and as you can see, the faster fitting is not fully drilled in because the hole was way too small. Eventually I redesigned that in Fusion and it worked. I It took me a few tries, but eventually I got the right size up. Now you can see that the faster fitting kind of moves to the side. And this is another attempt of the carriage, but it's a small chain link. And this is the actual one that I have on the 3D printer right now that you just saw printing. And this is another frame end that failed, and this is redesigned the frame end that actually worked. So now I'm taking everything apart to put the new 3D printed pieces together and finally have some wire management that I've been doing without for a long time. And as you can see, I have a fan below that fan. It's a bigger fan that I found, and they're 12 volts because I managed to break my 24 volt connection. There's no power in it, so I found one on the motherboard. I don't know what it is for, but I used that, and I had fans on hand, and I used those. Even though I used the oversized fan, I also had a smaller fan that would work. But I just didn't want to re-snake the wires through the chain, so I left it as is. And this here proved a little bit of a tricky part to find the screw with the screwdriver, to find the screw hole. It's kind of like dialing blind. And then after that, the other ones aligned properly. Just slowing down the video so you can see like how I used my hands to do this. Check it out. But it works. So now I'm installing the new frame attachment, which has a lip. As you can see, the lip right there where the faster fitting is, and then also to install that under lip on the inside, you may want to take that end stop out because it's such a painful process. And my 3D printer printed a little larger, and probably that was the problem, but eventually I kind of pushed through with longer screws and it worked. So here I modified the chain end. I could have done that in Mesh Mixer, but at the time I was at the loss for ideas, so I just cut it and installed it. Tested the length of the chain to see where it goes, and then got to printing a test. And this is with all the modifications, and this is PETG at 240 degrees with no fan, and no Z-hop, and no retraction of 4 millimeters, and a wipe for 4 millimeters. And these are just a view of the parts. The two parts on the back right hand corner are just a comparison. The one on the left back corner is the actual one you need to 3D print for the big chain. And as you can see, the ones to the right hand corner, one it's much thicker in the base where the stepper would be, and the other one on the left, it's a little thinner. And I'm just gonna move around for you to see how they measure in thickness one next to each other. And also you can see the chain ends and the chain links, and here I'm showing you how different the thickness is, and it does work as thinly as that, unless you want to pull with the sledgehammer at it, but otherwise it works. I'm just moving the parts around to kind of give you a better perspective. Okay, so that's the one with the chain end attached, and you can see the difference in the height of the actual designs. And if you care to, throw me a subscriber and a like, and I'll see you on the next one. But until then, I'd bid thee mon amis farewell and adieu.